Hello everybody, welcome back to chemistry. Today we're going to be talking about periodic trends. And there's actually 4 trends we're going to talk about in this unit. It's going to be atomic radius, electronegativity, ionization energy, and ionic radius. But before we can go into those 4 guys we're going to talk about, we're going to first talk about periodic trends in general. Okay? Now, when we're looking at periodic trends, there are 2 things that determine periodic trends. Okay? And if you analyze these 2 things, you should be able to get out the trend for any trend that they ever give you, even outside of those 4. Okay? Now, the first thing we're going to talk about is the Zeph. Okay? We're going to talk about the Zeph first. Well, what is the Zeph? That is the positive pull from the protons. Okay? There's like this positive force. I'm going to write that too. It's a positive force from the proton. Now, just like anything, if I have more protons, then I have more of this positive pull from the protons, right? So let me give you an example here. I'm going to draw a nucleus of an atom, right? If I have 1 proton, right, that means 1 proton has to be hydrogen. If I have 2 protons, that means it's helium, 3 protons, lithium, 4 protons, beryllium, right? But my point is, the more protons you have, the more of this positive pull you have, more of this positive force, okay? And that's what the Zeph is. It's the positive pull from the protons, okay? Well, why is this important? Well, you got to remember one thing. Opposites attract. Okay? Opposites attract. Well, what do I mean by that? Well, remember we talked about valence electrons, that they're the ones responsible for bonding? Well, when we start looking at what's happening with atoms, it all comes back to these valence electrons. Okay? So, what's going to attract a negative electron? How about a positive proton? Right? They're going to attract each other. And that's exactly what happens. So this is 4 protons, so we're looking at BE here. He actually has 2 energy levels, okay? And he has 2 on this one and 2 on this one. Remember, 2 can only go in the first and 8 can go in the next, but he only has 2. Well, these guys are your electrons. They have their negative charges, right? Well, what's holding these electrons here and in these energy levels? Well, it's the positive protons that's holding him here, okay? The positive protons are holding these electrons here. So, if I added more protons, that attractive force would become greater, right? It becomes stronger. So, there's these positive protons holding on to these electrons, and it's because of that Zeph pull from the protons. So, the Zeph has a lot to do with the periodic trends. It don't matter what trend it is, the Zeph has a lot to do with it. Now, when we're talking about the Zeph deals with the side-to-side trend you find on the periodic table, okay? When we're trying to figure out the trend for elements going side to side on the periodic table, side to side right here, see, side to side, we always look at the Zeph to give us the side-to-side trend, okay? Now, what is the second thing that dictates periodic trends? Number 2, okay? The second thing that dictates periodic trends are the energy levels, okay? The energy levels. Well, let's look. Remember, the energy levels, this is the first energy level, second energy level, third energy level, and as you go down on the periodic table, 4th, 5th, 6th, and 7th energy levels, right, on the periodic table. So, as you go down the periodic table, you're increasing by 1 energy level, right? So let's look. Hydrogen, we'll go back up here. Hydrogen has 1 energy level and 1 proton. See? Hydrogen, 1 energy level, 1 proton. Now let's look at lithium. He's the second one down there. Lithium, Li, has 2 energy levels because he's on the second row. He has 2 in this one. He has a total of 3, so he has 1 there. So look, we went down the periodic table from hydrogen to lithium, and we increased by 1 energy level. If we went to sodium, we'd gain another energy level. If we went to potassium, we gain another energy level. So as we go to potassium, right, which has 4 energy levels, I kind of wrote this crooked, but he has 4 energy levels, you can see that the radius, or you can see that the size of the atom is increasing as you go down the periodic table. So when we talk about energy levels and trends, the energy levels dictate the up and down trend on the periodic table. Okay? The energy levels dictate the up and down trend on the periodic table. The Zeph, the pull from the protons, dictates the side to side. Energy levels dictate the up and down. Okay? Now, one thing about these energy levels here, you're going to notice something. Say this is the nucleus, these red dots I'm putting in right here. This is the nucleus. As you go down, what's happening to the distance from the nucleus? The distance from the nucleus is increasing, isn't it? As the atom gets bigger, the distance from the nucleus gets bigger. That's going to be important to remember, especially when we start talking about Zeph later on. Okay? So, if you can apply these two, Zeph to the side, and energy levels to the up and down, you should be able to guess out any trend just by analyzing what's happening. Okay? So this brings me to our first trend. Okay? Our first trend we're going to look at is going to be atomic radius. The first trend we're going to look at is atomic radius. So let's look at the side-to-side trend first, right, for atomic radius. Remember, if I'm looking at side-to-side, I'm going to analyze the Zeph, the positive pull from the protons. So let's see what's happening. First of all, what is atomic radius? We're going to start with lithium as our example here. He has 2 energy rings, right, and he has 3 protons. So I'm going to draw 3 dots here. 3 protons, okay? Now, here's how this works. There's a pull from the protons on these electrons, okay? There's a pull here. Now, let's say this has a pull energy. I'm making up this number. He has a pull energy of 5. Let's say he has 5 pull, okay? Now, let's look at the next element in the periodic table, Be. Be has 4 protons in the center. You're still looking at 2 energy levels right here, right? Even though I'm not drawing this to scale, you still have 2 energy levels. Well, let's just go ahead and call this 15. Let's make this numerical. So 3 dots, each has 5 pull, right? 5, 10, 15 pull. How much pull force do you think this guy has? 5, 10, 15. He has a 20 pull, okay? He has a 20 pull. Now, think about this. Let's say you have a pull force, and I'm pulling you, and you're sitting there in one place, right? Let's see if I can draw this. He has to pull the electrons that are sitting out here, right? Well, keeping everything the same, if I increase my strength, shouldn't I be able to pull you in closer? Right? So with everything being the same, if you increase the protons, you increase the pull force, therefore the nucleus is able to grab onto those electrons harder, thus pulling them in closer. So what happens is, as you increase the number of protons, you actually contract the atom. It's going to get smaller as you increase the pull force. So what do you think is going to happen if I have 5 protons in here? It's going to contract it even more, right? What if I have 6 protons? It's going to contract it even more. So as you see, as you add the number of protons, keeping the same energy level, as you increase the number of protons, it contracts the electrons because it's pulling them more and more. Okay? So that's our first trend for atomic radius. We know our atomic radius gets smaller, I can't spell, smaller as you move to the right on the periodic table. Okay? The atomic radius gets smaller as you move right. What does it mean if you go left? What happens to the atomic radius if you go left on the periodic table? The atomic radius should get bigger, right? And why is that? Well, let's see. If I have, as I go this way, if I reverse it, I take away a proton, take away a proton. So if I'm taking away protons, that means I have less pull force. I can't hold on to the electrons with as much force, so the electrons can get away from me a little bit. So my orbital expands, right? So the more protons you have, the tighter the protons hold on to the electrons. The less protons you have, the less tight they hold on to the electrons. So there's your first trend for atomic radius. As you go right on the periodic table, your radiuses get smaller because you're increasing protons by 1. If you go left on the periodic table, your radiuses get bigger because you're lowering the number of protons. Okay? So that's atomic radius right here. This is your trend for atomic radius right here. If you go right, the radius gets smaller because you get more and more protons, so they pull it tighter and tighter. As you go left, you get less protons, so it pulls it less tight. Now let's talk about atomic radius going up and down. Up and down on the periodic table. Okay? Now, what did I say up and down? What dictated up and down? We said energy levels. Okay? We said the energy levels dictated the up and down. So looking at the energy levels, we know if we start with hydrogen, hydrogen has 1 energy level. Let's go down by 1 to lithium. See right here, what I'm doing here is going down this right here. We're going to do lithium, we're going to do sodium, and we'll do potassium. Okay? We'll do those 3 right there. Hydrogen is the first energy level. Lithium is the second energy level. Sodium is the third energy level. Potassium is the 4th energy level, right? So already you can tell what's happening, because with this scenario, we're going down the periodic table. We're going down the group, right? So what's happening to the atomic radius as you go down? So let's look. What's happening to the atomic radius as you go down? It's getting bigger, right? My atoms are getting bigger. So I know the atomic radius as you go down increases. Okay? What about when I go up a group? Well, let's go back this way, right? So potassium, go up to sodium, go up to lithium, go up to hydrogen. What's happening to my atomic radius here? Your atomic radius decreases. Okay? So your atomic radius decreases. So, guys, this is the trend for atomic radius. So let me do a quick recap. Let's make this simple, okay? I'm going to make this simple for you. Now I'm just going to give you the trend, okay? Now I'm just going to give you the trend. I'll show you how the trend was derived. If you're moving right on the periodic table, atomic radius, AR, atomic radius goes down, right? And if you're moving left on the periodic table, atomic radius goes up. And if you're moving down on the periodic table, atomic radius goes what? Bigger. And if you go up on the periodic table, atomic radius gets smaller. Okay? So there's your trend there. Okay? To make this even simpler, let's call this increases. Increasing atomic radius. We know the atomic radius increases as you go down, right? Down and to the left. Atomic radius increases as you go down and to the left. So atomic radius decreases as you go up and to the right. So there you go. This is the one you have to memorize. Atomic radius increases as you go down and to the left. So let's do a quick example. Who has the bigger atomic radius, right? Now remember, up and down, this is super important. Up and down always trumps left and right. Up and down always trumps left and right. And the reason why is, even if you add a lot of protons and you get that positive pull power, by adding another energy level, the distance gained from the energy level is just so great, it overpowers the pull from the protons. Okay? Let's do one quick example here, okay? Or a couple. Who is bigger on the periodic table? Carbon or nitrogen? Okay? So you're going to go to the periodic table. Who's bigger? Well, what dictates the atomic radius size? Well, it's bigger if you go left and bigger if you go down. So since these two are left and right from each other, whoever's the most left is the biggest one. So who's the biggest one here? Carbon is the biggest one, right? Let's do another example. If I had fluorine, chlorine, and bromine, who's the smallest one? Well, if you look at fluorine, chlorine, and bromine, it gets bigger as you go down, so that means smaller as you go up, right? And I want to know who's the smallest, okay? So if you go smaller as you go up, because my trend says you get bigger as you go down, well, who's the most up? When you're looking at up and down, who's the most up? Fluorine is. So fluorine is the smallest, and that makes bromine the biggest, okay? So that's really, really simple to do these trends. One last trend here, just to clear up any misconceptions, okay? We're going to do one last trend. Who is bigger? We're going to look for who is bigger, has the biggest atomic radius, between nitrogen and aluminum, okay? Between nitrogen and aluminum. Well, here's nitrogen, right? We know it gets bigger as you go down, right? And it gets bigger as you go to the left. Where who's the most down and left? Well, here's nitrogen. Aluminum is even more down and more left. So aluminum is the biggest one. Okay? Now, one more example. Who's bigger out of nitrogen and chlorine? Okay? Well, nitrogen's here. He's more left, but chlorine is more down, right? Nitrogen is more left, but chlorine is more down. So it increases as you go left, and it increases as you go down, but who wins? Well, remember this? Up and down always trumps left and right. So the biggest person is the one who's most down. Who's the most down one? Chlorine is the most down one, therefore he's the biggest. He has the biggest radius. Even though nitrogen is more left, chlorine is more down. And up and down always trumps left and right, okay, when we talk about periodic trends. So if you look on the periodic table, all the elements get bigger as you go down, and all the elements get bigger as you go left. So what's the biggest element on the periodic table? Well, who's the most down and to the left? Francium, right? Who's the smallest element on the periodic table, right? Go to the most up and to the most right. Down and to the left, up and to the right for smallest, down and to the left for biggest. I hope this answers your question on periodic trends and atomic radius. Y'all have a great day.